Good morning, everyone, again. I really want to welcome you all today to our webinar. The topic is called From Chaos to Clarity. And what we are going to do is we are going to take a closer look on how to have a pragmatic approach to scale data quality management systems. My name is Cornelia, and I am part of the sales solution management team of Positive Thinking Company. I am also specialized on our data quality solutions. Today, I will take over the moderation of the webinar. And without no further ado, I want to introduce you to our two data quality consultants and speakers, Vera and Lennart. Vera and Lennart, do you want to introduce yourself?
Yeah, hi everyone, also from my side. As Cornelia already said, my name is Vera. I'm specialized on data quality topics and representing mostly the technical side today. Yeah, you will learn more about this during this webinar.
And good morning also from my end. I'm Lennart. I'm a manager for data governance and data strategy topics with Deep Consult in Germany, dialing in from sunny Cologne this morning. And I'm more on the functional and process side of things. So this is really a unique combination that you will learn about more in this webinar.
Okay, so before we start, just a few organizational notes. In the bottom right corner, there are 3 tabs. First one, that is the chat function. If you have any remarks during the webinar, please don't hesitate and just post it in the chat. We have someone in the background who will take care of it. Then second one is the question function. And please, we really want you to participate today and give you the chance to ask us all the questions you want to know regarding data quality, maybe also about our approach or specific issues that you are facing in this matter. We will gather all the questions and we will answer them in the end in the Q&A session. We will really dive into your questions because what we want to do today is we really want to create a value for you and maybe even get into a little discussion. And then the last tab, that is our poll section. Be ready to get interactive today and answer some questions. And actually, you can get ready now because what I want to do is I want to start with a quick question. And that's it. That's this one here. So on a scale of 1 to 5, how much would you say data quality affects you? 1 being not that much or not at all, and 5 being this is crazy, like a lot. Okay, and while you answer the questions, I want to quickly jump into the agenda before we begin. First, we will start with the basic on what data quality actually is. After, Lennart and Vera will give you an insight on the 5 dimensions of data quality management. Then we will give you an example on an automated data quality management system that we implemented at our client, Publicis Media. We will also give you an insight on our approach on how to set up a scale and scale a data quality management system. And finally, there is time for the Q&A session. So then, let's begin.
Yes, so before we get deeper into the topic, let's quickly talk about the definition of data quality and how we define this interdisciplinary field in this webinar and also in our approach. Some of you might recognize the definition from the ISO 9000 norm. So data quality is the degree to which the data meets the requirements that you as an organization, as a company might be having, but also specifics of a certain use case. We see it as like an intersection of 2 different fields: data governance, which is like the main place for data quality, and there the processes part, the roles and responsibilities of data quality, they might be displayed in a data catalog or analyzed with data lineage. On the other side, you see here data science, which for us is a possibility to actually use topics like natural language processing, for example, for text data or pattern recognition, to do specific data quality checks and to support your data quality system with the technical side of things. Those 2 are coming together and are represented here today by Lennart and me. Leonard more for the processes, for the data governance side, me coming from the field of data science, and bringing this together in an approach for data quality that enables you to do your use cases in your company, talking about BI and reporting use cases, making sure that your data is correct for that, improving your decision-making processes, or enabling you for machine learning use cases. So let's have a look at the challenges and issues you might be facing. We see a lot of organizations facing the same problems when it comes to data quality. Looking at the poll from before, I see that all of you have the problem that data affects you at least a bit. Most of you picked 4 or 5, talking about data quality, that it affects you a lot in your daily work. And this is something that we see in other organizations as well. So there are 5 common challenges that are named a lot when we talk about data quality with our clients. One of the most specific problems is that there is a lot of time used to track down data quality issues and then also to mitigate them, because it's very business-specific data quality problems. A lot of organizations have the problem that they need highly educated staff that deals with those data quality problems and needs to track them down in a lot of time. This is something that can definitely be reduced if you have a good approach for data quality. Another topic is use case development. There is everyone talking now about generative AI and ChatGPT. It's a very modern use case that might be affected by bad data quality, but we also see this for more traditional use cases, that the data is not good enough or not even available, because in the organization, data quality is not one of the most important topics. And now, when you want to start with generative AI, you might experience the problem that actually you first need to deal with your data quality problems before you can start into it.
Exactly. Like a more traditional way of using data is to support decisions based on your data, on actual facts that are represented by data in your company. And obviously, if you have not the most reliable data or unknown data quality in your organization, it directly impacts the decision-making process. So people might resort to more of their gut feeling, and doing this in a more quantitatively supported way really is one of the goals of high data quality. Regarding the data usage, this is also a very common problem, that once people realize, oh, this data is not good enough for what I want to do, they lose trust in data altogether and also resort to things as they were in the past, maybe. So this really prevents the company from progressing towards a more data-oriented culture, towards more data-driven processes and decision-making. And adoption by business teams really is something that is a really obvious benefit of high data quality. Also, nowadays, all of you know that data volumes are steadily on the rise. So there's a lot more data than there was 10 years ago, 20 years ago, and the data is not at all structured. So it's really tough to keep all that data in check, and to do this in a rather manual way is even more difficult. So it's really one of the typical challenges, how to guarantee a certain level of data quality or needed data quality for certain use cases for this amount of data. Now there's another poll. So from the 5 issues that we just showed you and explained to you, what would you say the challenges are for you on your side? So while you're contemplating what you click, I want to quickly take a step back and look at data quality management from a process perspective. So from a process perspective, you, as a first starting point, you have your requirements. Requirements can originate from all kinds of places in your organization or outside of your organization. Of course, you have your use case, you have operational use cases, you use your data to control your processes, to decide whether part of a machine is going on the left conveyor belt or the right conveyor belt. So if that is if the data quality is not good enough for that, you have a problem in your core business. But then there are also the more analytical use cases, reporting use cases, financial reporting, but also the machine learning use cases that Vera talked about earlier. So there are all kinds of things depending on where your company wants to go. There are the data consumers, so people that want to use the data. Speaking more in a self-service kind of context. These are people that most likely know their way around data a little bit and can really express what kind of requirements they have. Then you have laws and regulations, obviously. For example, in pharmaceuticals industries, you have lots of regulations concerning data quality. You have to report the right data, and if there's something wrong with the data, then obviously you have a problem with the supervisory authorities. Banking is also very regulated. And then, as a last point that we have mentioned here, there are strategic initiatives. So nowadays, most business strategies in some capacity are relying on data to drive future development of their company and their growth also. And for this, there are also are a lot of requirements coming into our data quality process. So what you do with this is actually you build kind of a framework. So you translate these requirements to data quality checks. You develop metrics like how to measure, if the requirements are met or not, and maybe something in between, like not quite or something like that. To signal to all the stakeholders in an understandable way whether they can use the data without any further concern, or whether they should do other things first to improve their processes, their data management practice, or any type of process step where data quality is really is decreased. So from this point, you can actually start a process cycle that will improve over time. You have your data quality checks. You apply those checks against the data that you specify, and then you get a lot of results, right? And from these results, you have to analyze further whether they are whether they mean something to you, whether they really detected an issue, or whether it's something that does not measure right, or whether it's something that is perfectly okay. And then you have your findings, your data quality findings that you will prioritize according to the negative impact on your business that they have, according to business priorities, obviously. And then you can start designing mitigation strategies for those findings. So you can think where to fix them, if you can fix them at all, or if you have to work around them a little bit. And once you have these strategies, then you can start implementing those actions. Ideally, you take the learnings from this process cycle and maintain your data quality framework in a way that it's better when you go through it next time. And then you start all over again. So that's basically how, on a very abstract level, seems very simple at this stage, how you run data quality management. And we always find it helpful to break down data quality management into 5 key dimensions to kind of separate the topics a little bit and make this their own subdisciplines. So as a first dimension, we have data quality criteria and indicators. That's basically everything you need in order to measure. So how do you measure actually your data quality? What does it mean for you? How do you measure it? Then you have the roles and processes around it. So how do you actually do that? Who do you need for it? And what are these people doing? You have reporting and monitoring. How do you present this in an understandable way, in an accessible way? And how do you also trace your data quality issues? You have technology, the full tech stack and architecture and tooling that you need to implement all this. And you have mitigation, the strategies, how to get rid of data quality management or data quality issues and how to fix them or how to work around them. And in today's webinar, we will concentrate on the criteria and indicators, roles and processes, and the technology part. We save the other two for another time. With that, I will hand back to Vera.
Yes, before we get started and deep dive into those 3 dimensions, we just quickly wanted to tell you our approach, how we actually get started with data quality. It's a very, very big field, and sometimes it might be hard to start. You might not know where to start, and you might have the feeling it's like a huge thing you need to do before you get value out of data quality management. So our approach here is to start small and to scale fast over time, meaning that you actually set resources free right away in the beginning. Looking at your challenges, I see that time effort is for a lot of you a big challenge in data quality or before data quality. So this actually, gives us right here in this point, because we really drive for setting resources free very early in the process. So the idea is to set the ground right away in the beginning to have valuable data quality control. Therefore, we define data quality criteria and indicators that fit your organization, that are tailor-made for you, that are adaptable over future, but that is the set that you can work right away from the beginning, work with, and can get started with your data quality management. We then define together high-value use cases, meaning that we really have a look at those use cases that need a lot of time, where a lot of people are involved, or people that are highly educated that could do other things than tracking down those data quality issues, to actually set the resources free right away from the beginning. We start with a very small technical infrastructure version. So the idea is that it's the leanest possible version that you can have to really get started. So a couple of checks. We get a bit more into the technical parts later on to make you understand what we understand here. And then after you have set the foundation, we start to scale the whole thing. So we start with rule-based checks, meaning that very easily from the beginning, the checks solve your manual work problems, that they actually replace the work that you are doing. And then later on, we scale over time, doing more sophisticated checks, supporting you on data quality checks with more sophisticated methodology, meaning perhaps statistics, perhaps also machine learning approaches, and then scale the system over time to more data sources, to more use cases, perhaps also more data quality criteria and indicators that you might having, but to adapt the system. So right away from the beginning, you have a first value that helps you, that supports you, that frees resources for you, and then later on, you maximize the value over time to make sure that you have the most value out of your whole solution. So let's have a look at the first dimensions.
Yes, so the first step in improving anything is basically to measure and find out where the actual problems are. So the first dimension deals all about making sure you can actually measure data quality. And what you need to do for that is basically you have to know exactly what is required. It's a pretty difficult thing to do from my experience, because people don't really know how to formalize their requirements. But with a little help, this is basically this is definitely doable. And then you have to define the metrics to make sure you can also have something that you can communicate. And really compare it to other other data quality requirements. So we always think of DQ checks as threefold. Each DQ check has to have a scope. So basically, you have to define what the data is that you want to apply a DQ check on, that you want to apply a criterion on. This is just to avoid noise in your result data. So it's a different thing if you just check like half of your customers for a certain criterion, than to check all of them. And if half of the valid customers have a problem with this DQ criterion, then you have 50% data quality or 75. So it's a totally different thing if you include something that is not really in scope of a criterion. Then you have to define the criteria. Basically, this is very conditionally thought in a rule-based sense, but could also be statistical analyses, could also be something that a machine learning model that is trained with valid data does. So this is really, as Vera said, something that scales along with the system. And then you have the metrics, so really the figures, the key figures, the KPIs, maybe aggregated into kind of traffic light system or something that is really understandable and communicable across your organization. And then there's this process that you need to run basically any kind of data product. So this is our very generic data product framework. There's product and project management to support actually the requirements gathering and keeping track of budget, time, and quality of the product. You have governance and strategy processes that really set the framework for how this can work and how this works in your organization. Who are the stakeholders? Who need to be informed? And then you have the actual creation and operation processes. So you have to design the solution, you have to implement it, and you have to operate it. So sounds like a lot of people are involved, right? So you have product owner, project manager, you have solution architect, data engineers, you have data producers, consumers, you might have machine learning engineers, data scientists. And on the governance and strategy part, you also have all the data owners, the data stewards, data strategy experts, and stuff like that. So now you might think, but wait, you said that you can start small, and actually you can. This is just like like a target picture, and also depends on your individual organizational structure. If you need all those roles, if you have like persons that can cover multiple roles in this, so it's really up to an individual organizational and procedural design. But you actually, to start off, you basically need 2 people. Admittedly, those might be a little hard to find because they must be able to do a lot of stuff. But in our use case that Vera will present later, this was basically the setup. So you have for the design process, you have someone like a business owner who can gather the requirements, who can design processes and really deep dives into the use cases to know what they are about. He can define metrics, can be very simple for a start. He can also derive the real, like the actual checks, the criteria from the data requirements. And then you have to have someone like who really knows their way around data, also from a technical perspective, who can implement an MVP style prototype, or not a prototype, but an MVP based on like a modular architecture that can be scaled later. So for example, start with where you don't need like the full extent of a final solution. You can start with something like a dummy, and then you can replace that later. So it's really key to keep that modular. This data person has to be able to set up database structures, because we need some place to store all the DQ checks and to also store the results. And he has to be able to, or he or she has to be able to design the access patterns, defining the data pipelines and populate them with the actual checks from the repository. And then he also has to define the data quality reports. And then the business owner can use all this, assess the validity of whatever comes out of there. So basically, this is like a quality check on the quality process, and can determine improvements from that for the next iteration of the product, and also for the really valid results that come out of this. They can derive the action plans, the mitigation strategies for the DQ issues. So basically, that's all you need for a start. And it's not as big as it seemed in the first place, but still you have to keep in mind that to run this product in the over the long time, you might need some more staff. All right, and for the technical part, I will hand back to Vera.
Yes, so let's get a bit into the technical side of things. I already told you that we want to start small with the leanest possible infrastructure to also fit the processes and roles that Leonard was just pointing out. So the idea is to have a baseline data quality infrastructure you start with and to scale over time. So what you really need in the beginning is quality checks. So you want to check something on your data, make sure that your data is available, that your data is, for example, there are no missings inside. So you would have a quality gate consisting of a couple of quality checks that you then apply to your data. Might be new data, might be uncertain data in your existing database, but this is really the beginning of the infrastructure. To make sure that this is executable within your existing infrastructure, you will need an orchestrator that actually triggers the execution of your quality gate and your quality checks. The results of the quality check and also the execution information for the orchestrator are stored in a database. So it makes sense to have a central database where everything is running into, where you get all the information from later on. So the orchestrator takes the execution information from a mastermind database and orchestrates the quality gate. And then the result of the quality checks are saved in this database as well. Over time, you want to scale this technical infrastructure to make sure that you also, for example, can display your data. So you take this very basic starting point and make sure that you can, for example, display your quality criteria in a nice place. So something that is understandable for people that are perhaps not so technical. As Leonard was saying before, it might be, for example, a traffic light system or quality levels that are shown in a dashboard, for example. Also, to make sure that you adapt your model over time and trigger adaptations of, for example, thresholds, you will need a monitoring that makes sure that you understand when your quality, for example, is changing or quality checks need to be adapted because quality is going higher or lower, to trigger, for example, retraining, to adapt the thresholds and to make sure that you're always up to date. From this displaying reporting option, you then might want to derive automized or manual mitigation strategies. It's a bit gray here because it's not only a technical topic. You might have mitigation options in an automized way, but it's also possible to do manual mitigation. It always depends a lot where the problem is and where you would find the problem. There are some things that you might want to do every day. You might want to fix this every day because you're not able to fix your problems on source, so you will need to fix them during the process. So it's very useful to have an automized option here, an automized way to mitigate your data quality issues in the technical part as well. Then for sure to apply your data quality checks over time, you will need a reliable delivery pipeline, meaning that you can understand your data quality checks and how they actually influence the production. So as in every software project, you will need here a dedicated delivery pipeline and make sure that you test your data quality checks on some sample of data first to see how it will interact with your data over time. This might be, for example, testing topics, might be also versioning things, but everything that's connected to a delivery pipeline, you will need it over time in your data quality assurance as well. And then my favorite topic, you might be able to apply machine learning to your data quality problems as well. This can happen in a lot of ways. So machine learning here is really just an add-on. It's not necessary to do data quality. We all know this, but it can definitely support you in a lot of ways. You might want to work, for example, with machine learning-based quality checks, meaning that, for example, you can detect anomalies, or you have text data that you want to assess and make sure that it's correct. And then you can definitely use machine learning to check this in your data quality checks easier. You want to support your monitoring, perhaps with machine learning. So for example, I was saying before that data quality might change over time, and to actually notice when your data quality is changing, and you see, for example, data drifts, machine learning might be very helpful. Also, if you have a big amount of data quality checks coming together, it might be very helpful to support this with machine learning. And also for mitigation, this can be very helpful. I was talking about natural language processing already before, and supporting texts and correct texts. So for example, if you just have typos in your text, it can be very helpful to correct this in an optimized way with machine learning. So this is in the end what you might need as a whole technical infrastructure, but very important, as I said in the beginning from our side. You can start small and really design something that fits you and your existing infrastructure, and then later on scale. We're not talking here about specific technology. It's really just a framework, how we use different technologies, how we would also use your technology and your infrastructure to build a technical solution that is directly fitted and tailor-made for your specific tech stack. So let's have a look at the data quality management use case that I did at Publicis Media. So very quickly, just to name some key figures about what we achieved with an automated system there. We actually achieved a reduction of issue detection time. So to track down the data quality issues and also to mitigate them, we were able to reduce this time to 50 to 70%, depending on the use case. We expect an amortization time of around 3 years. Can be less, actually. Right away at the beginning, we have some very valuable use cases that we started with. Depending on what they implement now as additional quality checks, it can be even faster because they're still in the process of freeing resources here. And also they're able now to actually check 100% of their data. Before that was not possible, but every data source that is implemented, they can regularly profile them on a weekly or daily basis. So let's get into what we actually did there and what is the setup. So Publicis Media is one of the biggest advertising service providers, biggest players in media. They're international, and they have a very big data platform that they analyze the data for example, campaigns, so all their marketing and media activities with. It's a very big data platform, and it serves a lot of business units. So there is a lot of data coming in and out every day, and it's a huge platform. The goal here in this use case was to actually enhance the existing data products that are also, some of them client-facing, some of them very critical in business decisions, to make sure that they have high-quality data. The challenges were that they, as a lot of you were having the problem that they manually detected data and lost a lot of time with this. There were people that were highly educated that were checking those data every day and making sure that the data is correct. That was very time critical, so a lot of pressure on the people as well. A lot of stuff needed to actually do this. This resulted in trust issues between the data engineering team, so the platform team, and on the other side, also on the business side, because sometimes the data quality was a bit poor, also related to the advertising platforms, because not all the data that was delivered to the data engineering team was super good. And to actually make this transparent, a data quality solution was needed to improve the trust between the teams and make sure that the business units were getting very good data that they can trust, and not to have to check everything once again from their side. So the need was there to have an automated data quality assurance solution and make sure that this data is checked regularly and on a high scale. You might recognize some of the approach points from before, because we sticked to the way of how we approach data quality problems here as well. We analyzed the current situation, so we were speaking with all the stakeholders there and made sure that we had all the requirements. Very quickly, we found out that data availability was one of their biggest issues, so they needed to understand at what point of time the data was coming in, how the status was, and how the process, how fast the process was, so that they could know at what point of time they could expect their data. Is the data recent or not? So we identified the most important quality checks that would provide the most of value for the business units. We designed and implemented a specific and tailor-made data quality infrastructure. The point was that there was an existing huge platform, as I said before, and we needed to fit a model directly into this platform, to have something that is tailor-made and customized for their needs. We created specific quality levels. As Lena was saying before, this can be very simple, and we started very simple here as well, with very simple quality levels, very understandable for everyone, being able to adapt this over time. But the idea was really that in the beginning, it's not a complicated system, and we implemented necessary roles and processes around it, so data quality checks and also the mitigation could be executed. We then designed and implemented the first quality checks to different data sources. So as I said before, there were a lot of data coming in from a lot of different sources, and it made sense to not use all the data sources in the beginning. So we started with a small set of data sources to prove the value of those quality checks that we choose, and then wanted to roll it out later to different other data sources. We created a reporting system to monitor the data quality and to show this, to display this also to the business units. And then we scaled the solution after successful first data quality checks to other data sources, to more checks, and also improved the infrastructure with everything that you saw before. We also enabled the teams to use this whole solution on their own. So the idea was really that over time we could go out as a consulting company and leave them enabled behind, so that they can actually operate and further develop the solution on their own, and make sure that they free more resources over time and use the time for something more relevant. We achieved a reduction in the issue detection time of 50 to 70%, and the mitigation time was also reduced by a lot. The data was profiled completely. Before, they only had the possibility to profile samples of their data. So now they could ensure that the data is of high quality. The business units were happy because they really saw the improvements, and they could also see transparent of how the data is actually processed, which quality checks were performed, and also if they have new requirements, bring them in. Probably there will be an amortization time of 3 years. Could be less, as I said before, because there are still quality checks that they're implementing that is helping the whole platform and process over time. That was the use case at Publicis. And now let's have a look at our pragmatic approach to set up and scale the data quality management.
All right. So as Vera mentioned, and I think it became clear from what we mentioned so far, when you start, you probably, when you start without anything, you probably see this mountain to climb ahead of you, but this is really a journey. And this is all about keeping consistent or making consistent efforts towards a higher level of maturity in your data quality management solution. It makes sense to define some milestones, and that's what we did with this maturity model here. So on the y-axis, you see the business value created by data quality management. So it starts very low, and it goes up over time, which is the x-axis. But it also adds some complexity to your organization. So you have to be able to run this. So it makes sense to grow this instead of just aiming for the highest level right from the beginning. So level 0, just to explain this a little bit, level 0 is a rather decentralized approach where you have lots of manual, probably sample-based data quality checks using kind of standard reports or standard SQL queries on your database where you have pull sample records and look at them basically, or feed them into an Excel template. But you need a lot of people to do that. Level 1 is basically automating this and upping the scale. So checking all your data, all your relevant data. This is primarily rule-based, probably. So you basically take the conditions that you had before, the requirements that you had before, maybe complete them left and right where there are low-hanging fruits. You put all the infrastructure in place, you put all the processes in place, then you basically lose a lot of necessity for manual efforts and free up resources, as we all said in the beginning. And then when you want to really scale this, you start introducing machine learning. What do you do with machine learning? Vera mentioned this quickly, what the perspectives are in the tech setup. Basically, you support your data quality checks with machine learning. You automatically detect anomalies. Obviously, this is also kind of a longer term effort, maybe. Because obviously you need to train these models, you need to develop them, you need to calibrate them, and you need to train them with good data. And it can also help in basically maintaining your rule set, because when you have a rule-based framework, then the rule set is growing over time. It's really becoming large at some point, probably, and you have to maintain this. You have to keep this up to date, see whether rules are discovering any issues at all, and machine learning can really help you in automating that. And as a final maturity level, we have machine learning driven data quality management, where you really use machine learning to discover, to prevent, and but also to mitigate the data quality issues. You might also think about monitoring this in an automated way. So this is really the possibilities are, we're just beginning to discover them, actually. And I feel very good about the coming years when it comes to using machine learning in all kinds of contexts. And for data quality management, the benefits are really obvious. So having explained this, we want to quickly ask you, how would you rate your organizational maturity level when it comes to DQM? So basically, take your pick real quickly. To give you an example of this, when we look at Publicis Media and what Vera just said, we figure they are somewhere between levels 1 and 2, but closer to 1. They have all the infrastructure in place, they have all the roles and processes in place, but they are right now starting to look at the possibilities of using machine learning. But the framework is capable of organically including machine learning, so they don't have to change a lot to do that. So we feel like the potential is really big, and they might be kind of fast at developing the first machine learning applications inside the data quality framework. So now that you've heard all about this, you might think, oh God, I have a lot to do. But no matter where you are on your data quality management journey, where you are in your maturity, we can offer you a lot of support. We can start when you basically don't know how to start. We can come in and support you in assessing your current data quality management solutions. We can look at what a good action plan could be. We can basically help you get a clearer picture of where you currently stand through structured assessment and interviews. When you're struggling to find the right way to measure data quality and don't really know how to formalize this and how to keep this consistent over all the over all your operations, then we can help you in defining this. When you struggle to implement this in a technical way, in a consistent technical way, and have decentralized solutions everywhere, we can also help you with that. We have a lot of data engineers and business analysts who can really design and implement such a solution. And also the monitoring of the results, the monitoring of your current data quality, or also the scalability of reporting solutions. This is also something that we can help you with. And the most exciting thing, obviously, for Vera and her data science and machine learning coworkers is the machine learning, uncovering the machine learning potential for this. If you plan on introducing this, and if you plan on automating lots of or large parts of this, this is really something that we can also assist you with.
Let me see. Oh, wow, there's a lot. Let's start maybe by the time that they were posted. So Julian asked right in the beginning one very interesting question. When setting the high value use case, should it be a use case where we know there is a data quality issue?
Leonard,
I can try it, or you can do it.
No, go.
Okay. Obviously, if you already know that there are issues, it makes it really easier, a lot easier to sell. That was to sell the benefits of having a good data quality management solution. But if you don't have any data quality controls, any organized data quality controls at all, chances are you will find something regardless. So, and you will find things that people don't really anticipate. So I would say it's a benefit to know that there are data quality issues, but it's not a requirement. And if the solution is really, or if the use case is really high value, then it also might be a benefit for the stakeholders of this use case to know that there are not a lot of data quality issues. So they have more, they have more trust into their use case solution. So it depends. Very diplomatic answer. Vera, you want to add anything?
Yeah, I just quickly wanted to add up that if there is so what we saw at Publicis, for example, is that for specific problems, specific data quality issues, there was a lot of time used to actually provide good data in the end. So if you have something like this where you know that you can free resources because there are people that have a lot of time dedicated to this and lose a lot of time, then it makes sense to start with a data quality issue that is very known and that is very important for you. If not, we will find out together what the perfect use case is to start with, as Leonard was pointing out. Let's get to the next question.
Yes. The next one is also from Julian. How do you define the right amount or upper limit of metrics to track to ensure good data quality?
Leonard, I think this is for you.
Yeah, I can take that. It also it also kind of depends, right? It makes sense to find a level that makes it still comparable. So I wouldn't introduce too much so people get confused all the time. But also, I would say that different requirements or different use cases may require different metrics. So some people want their negative effect measured in euros, or if you talk about, I don't know, machine production precision, you may have accumulated weight, or I don't know, like volume of kind of the machine part that is produced. So it's really up to the specific use case, but in the end, it makes sense to surround the individual the individual metrics that you check with a kind of threshold framework. And the thresholds will then make the check run into basically when you aggregate all of them, they basically sum up into a traffic light or some kind of percentage system. So that way you can present an entire level of data quality for a selected amount of checks without confusing everybody by all these different metrics. But the individual metrics are, I mean, the sky's the limit, basically.
Okay, I think we have to hurry up a little because there are more questions coming in and there's not much time left. But Marie, she's asking, can you give an example of different data requirements depending on different use cases?
Absolutely. So I think I mentioned the example already before, right? So some effects maybe, or let's say if you, for example, go into real estate, or look at real estate use cases, and you, I don't know, want to report the number of apartment units that you rent out to or that you lease out, and then you have, and then you measure this over time, and you basically want to make sure that the number of apartment units in one building is consistent. So this is something different than, I don't know, requiring that the postal code of your customer is always the same across many systems, or the if you want to geographically sum up kind of your business, your different stores are always put at the right address, so to say. So there's a lot of variety in use cases and requirements. It's really hard to come up with them with a comprehensive set right off the bat. So it depends on your individual business, on your use cases, and also on the stakeholders, what they respond to best.
Okay, good. Thank you very much, Leonard. Then a question from Alex. What main differences are there between an ML-driven DQM, data quality management, and the non-ML-driven? What are the pros and cons?
Yeah, that's a huge question. I think I will answer it a bit quickly because there are also more interesting questions, and we want to perhaps do one more. So in the end, machine learning driven means that everything is based on machine learning in your data quality approach. This doesn't mean that everything is machine learning, but it means that you really have the possibility to understand your whole system better with machine learning. If you're good in machine learning and you already know in your company that machine learning makes sense for you, it is easy to start the process with a machine learning supported system, and it's also easy to get into machine learning driven data quality management. Easy in the sense of that you have the tools. It will definitely need you a lot of time to get there. It's nothing that you will reach tomorrow. But it's not something that is useful for everyone. There might also be checks that are useful to do them non-machine learning driven. It makes sense to not optimize everything with machine learning. So from pros and cons, it depends a lot on your organization. If you have the skills or if you don't have the skills to do machine learning, you can always build up the skills for sure. It will definitely help you. It's not an end in itself, machine learning. So we will not use machine learning for everything in your solution, but it can make sense for a lot of use cases to go into the direction of machine learning here. I think that's in short, and probably we don't have time for another question, unfortunately.
Yeah, let's see. Okay, so we have 2 minutes left. Maybe you try with one more or, okay, let's see. So one more that would be, what if I realize over time that I might need additional data quality criteria because new use cases are coming up, or we realize that we cannot work with the ones we identified right away in the beginning? Just for everyone who has typed a question here, what I would suggest is you can actually send us your questions afterward. You can also post them on our LinkedIn page, and for sure we are very happy to answer them then afterwards, because the time is running out. Thank you. Good. I think then, sorry, I thought we might have time for this question, but I think that was it. So, all right. We are coming to an end today of this webinar, and I really want to thank everyone for your attendance and participation on this webinar. I hope that you were able to take away a lot of new information that you can use in your daily business, and some last organizational information from my side. You will get a replay of this video plus the presentation sent to you afterwards. And of course, if there are any questions that arise afterwards, or as I said, that you have posted and that were not answered yet, you can contact us anytime. We are very happy to give you some further advice. And yeah, that's all. Thank you very much again, and bye-bye.
Thank you. Bye.
Thanks, everyone. Have a good day.